So today we're talking about rotations on rotational symmetry, a transformation in which a figure is turned about a certain point. So there's three things we need to know about a rotation. We need to know around what point. Another word for this is about. So what is the center of this rotation? Okay, in what direction it's going. If it's going clockwise, that means it's going negative. And if it's going counterclockwise, that means it's positive. Okay, and then how far? We measure in degrees for rotation. So how many degrees? Okay, so clockwise is a negative direction of rotation. So it's starting at this star and it's going to this star. So this picture shows that it's rotating around our origin and it's moving 45 degrees clockwise. Counterclockwise is moving in a positive direction. So if I look at this picture, it's starting at this star right here, and then it's moving this way. Again, it's got the same center of rotation, the origin, and this one tells me it's moving 120 degrees. Someone's music is way too loud. On the first one, it wants me to tell whether it's a transformation, whether the transformation is a rotation around the origin, and then if so, give the angle and direction. So if I take a look at this first one, I start at this picture, and then if I rotate my picture 90 degrees, this looks just like that one. So I'm going from here to here. And this is going to be 90 degrees counterclockwise. Okay, so I want to pay attention to this shape. If I if I notice, the long side is on the right. So if I move this like this, is the long side still on the right? This is the long side? No. So this one is not a rotation. Okay, so then if I look at this one, my up and down side is on the left. So if I spin this around, is my up and down side still on the left? Yes. So this one is 180 degrees. And this one can either be clockwise or counterclockwise. 180 is special that way. Counterclockwise. So this one wants me to draw the image of each figure after the given rotation about P. It wants me to go 45 degrees clockwise, so that's going this direction. So this is a rectangle. I want to twist it just a little bit like this. Then my other one is 270 degrees clockwise. So that is going to turn it like that. So if I move this picture like that, this is what I want it to look like when I draw it. So I want the arrow pointing down. So I'm just going to sketch this out. Thank you. Okay, this one wants me to move the smiley face. This one is saying counterclockwise. So this is opposite the direction of the clock. If I'm starting here and I'm going 90 degrees, this one is going like that. So that is moving the paper like this. So I want the smiley face to be sideways with the mouth on the left when I draw it. Okay, my next one is 240 degrees. So that is going to be like that. So I want to turn the paper. That's 90, 180, And then, oops. So I want him to be kind of diagonal with his smiley face part up there. So that's going to put him over here, and his smiley face part right there. Then I have 180 that is just going to go like that. So I turn the page, and so this is 90, this is 180. So I want to flip the smiley face upside down. That is going to go here in this top corner. And then my last one is 360. This is a complete circle, so this is the same as where I started. Okay, this next one wants me to use my straight edge and a protractor. The protractor is this half moon looking piece. I am rotating 180 degrees counterclockwise around the origin. It wants me to name the vertices of the image and compare with the vertices of my pre-image. So just like when I have reflections that are on my origin, when I have a rotation that's on my origin, notice this point O is on the origin. If I spin that around, it's going to stay where it is. So my O prime is still going to be 0, 0. We'll start there because that's the easiest. Then what I want to do here is, if you notice on the protractor, right here I have a little tick mark in the center. That is telling me where to place it when I want to move something. So if I want to move point Z, I am going to put the tick mark on the Z, and I want to line it up through my origin because that's where I said I was rotating. And no, I did that backwards. The tick mark goes on the origin, and the line just goes through Z. So I want to go 180 degrees. If I look over here, the top number is 0. You can't really see that because of the glare. But if I go all the way this half circle, 180 is over here. So what I'm going to do is I'm going to draw a line straight across. And then I need this to be the same distance away, so I'm going to go ahead and measure from 0 to Z, which is an inch. So I'm going to go an inch the other way and put my dot. So my Z prime is at -3.5. Then I'm going to do the same thing for my X. So I'm going to line this up. The tick mark goes on my origin. My X goes through the line. This one's another straight across line. So I'm going to go ahead and just draw my line. I'm going to measure this one in centimeters. It is 2 centimeters away. So I'm going to go 2 centimeters away the other way. So right here is my X prime. And this one is at 2.3. Okay, so we're going to write some rules for our rotations. If I'm rotating 90 degrees counterclockwise, I want to switch my x and y. And then I want to multiply my new y coordinate by -1. So this is going to turn into -yx. Uh, 180-degree rotation, I want to multiply both by -1. So this is going to turn into -x, -y. A 270-degree rotation, I want to switch x and y, and then I'm going to multiply my x coordinate by -1. So this is going to turn into y, comma, -x. So then using these rules, I want to fill out this table. If I start at 411, a 90-degree rotation turns it into -11.4. A 180-degree rotation, this is the one where I multiply both by -1, is going to turn it into -4, -11, because I'm looking at my pre-image to get this. Then a 270-degree rotation, I take these, I switch the numbers, and the one that is in the second position changes signs. So if I start at 7, 180-degree rotation makes both of those negative. And a 270-degree rotation switches the numbers, so 7 and 7 switch, and then the second number changes signs. Okay, then I have C is 4, 7, so 180 degrees is going to make that -4, -7. Then a 270 rotation is I switch the 4 and the 7, and then the 1 in the y value spot turns negative. So my D starts off, for any random point, is going to be x, y. A 90-degree rotation switches the letters and makes the first one negative. 180-degree rotation makes both of them negative. And a 270-degree rotation switches the letters and makes the second one negative. So number 4 gives me these points, and it tells me it's doing a 90-degree rotation. So I'm going to follow the rules of switching x and y and making the first one negative. I'm just going to start off by plotting these points. So I have 1, 1 is my P. 4, 5 is my Q, and 5, 1 is my R. So then for my P prime, I am doing 90 degrees, so I switch the numbers and make the first one negative. So I switched 1 and 1, and then I made it negative. So negative 1, 1 is my new P. Then for Q prime, I do the same thing. So 4 and 5 switch places, and then the 5 turns negative because it's in the first spot. So I have negative 5, 4. And then R prime, I switch my numbers, the 1 and the 5, and then the 1 turns negative because it's in the X spot. So now I have negative 1, 5, positive 5. So number 4 is having me do it 270 degrees. So I'm going to start off by plotting my points. I have negative 5, 1, negative 2, 3, and 4, 0, 4, 0. So this one is 270 degrees counterclockwise. This one is switching X and Y. And then make the second number negative. So for my A prime, I'm going to switch the 1 and negative 5. So the 1 goes first. And then when I move the negative 5 over, it's going to turn into positive 5 because I have to change its sign. So then this is my A prime. Then for B prime, I switch the negative 2 and the 3. So the 3 goes first. And then because the 2 was already negative, I'm going to turn it positive. So now my new point is 3, 2. And then for my C prime, I switch 4 and 0. So I have 0 first, and then the 4 turns negative. And then I just connect my points. This one says that the triangle is shown to the left. What is the image of point J after a rotation of 270 degrees counterclockwise about the origin? So again, this is switching X and Y and making the second number negative. So I'm only focusing on the letter J. I'm going to have J prime. So the -7 and 3 switch places. -7 goes first, and then my 3 turns negative. The last thing we're going to talk about is rotational symmetry. A figure has rotational symmetry if a rotation, clockwise or counterclockwise, about its center, produces an image that maps onto itself. Between 0 and 180 degrees. And then an important thing to notice is everything maps onto itself at 360 because you've completed a circle. So if I take a look, this is a square at 0 degrees. That's what it should normally look like. At 45 degrees, it doesn't look like a square, or at least not in the same orientation. But at 90 degrees, it does. So this one has rotational symmetry. Okay, so if I take a look at A, if I spin this 90 degrees, does that look like my first picture? With the big diamonds on the top? No. And if I flip this, this is now 180. Does this look like the same with the big diamonds on top? No. So this one does not have rotational symmetry. So same thing for B. If I spin this one 90 degrees, does it look like my original? Yes. And if I spin this one 180, does it? Yes. So this one is, yes, 90 and 180 degrees. Okay. So on C, I have, it's really long sideways. If I spin it 90 degrees, is it still really long? Is it still? Nope. I cannot talk. If I spin it 180, is it really long sideways? Yes. So this one is only 180. Okay, so then I just have these last ones. This octagon, I want the flat side on top. So if I spin it like this, is that flat side on top again? Yes. And I can keep doing that until I've gone through all 8 sides of my octagon. So what I'm going to do is, this one is yes. In order to figure out how many degrees I'm rotating it, I want to do 360 divided by 8 because there are 8 sides in an octagon. So 360 divided by 8 is 45. So every 45 degrees, it's going to go onto itself. So I have 45, 90, 135, and then I just stop at 180 because everything else is repeating. So my parallelogram, if I spin it 90 degrees, does that look right? Like how I started off? Nope. What if I spin it 180? Does that look like how I started off? So remember, I started off with the pointy side on the left. When I spin it upside down, is the pointy side still on the left? Yes. So this one is 180. And then my last one is this trapezoid. So I have the short side on top and then the slant on the left. So if I rotate this 90 degrees, is the short side on top? The short side? No. And then if I rotate it like this, is the short side on top? No. So this one is no rotational symmetry.